My name is Rohan, and today I will be presenting to you the updates on the PiPlant version 2.0 as part of my CS research project for the winter term. So I'll just be quickly recapping what happened in the fall term. So the PiPlant is essentially is a virtual assistant plant that works off of a Raspberry Pi. It uses sensor data to accumulate information about the plant and its vitals, such as temperature and humidity, and it uses that information to talk to the user with a bit of a snarky attitude. So last term we did a lot of the heavy lifting in terms of figuring out the scope of the project and thinking about how the sensors would properly integrate with the user. So these diagrams, courtesy of Sky, who was my teammate last term, she made these diagrams to depict the different aspects of the project. So for instance, this diagram kind of shows the way the plant sensors will be flowing into the Raspberry Pi and how that will impact our plant AI and the web interface, which are the two different parts of the project. We used Flask API, which is a Python web-based backend that is used to take the sensor data from Raspberry Pi and put it on the website. The front end is done with the Flask API as well as d3.js to make the graphs. And the virtual assistant, which is the AI, is done using speech recognition libraries to interpret what the user is saying. And then we wrote some custom code to interpret that command and relate it back to how the plant should respond, and the plant generates a response. So starting from after winter break ended, when we came back, I talked to Mr. Viola about using a Asus Brick mini computer, which is essentially like that one over there. So this had Windows 11 flashed on it, and the intention behind this was it was a little bit difficult to work on the Raspberry Pi just due to its speed, and we thought it would be cool if we can use a Windows computer to imitate the same thing. So Mr. Viola graciously let me borrow one of these computers to work on during winter break. And then I purchased some PL2303TA cables. These are essentially USB to GPIO input cables that you can plug your sensors into. But what had happened was when I plugged my sensor into the Asus computer, the system quote unquote blew up, where you could feel the ultrasonic sensor burning in your hand, and it smelled, which is not a good sign. And the USB port got corrupted. Luckily, it was just a matter of restarting the computer and plugging the thing out, and it was all good. But I felt like if I had continued down that line, it would have been a lot worse. So after that, and having a couple of driver issues where the cable said that it wouldn't be compatible with Windows 11, Mr. Viola was gracious enough to give me a Raspberry Pi 4 to continue the project. Currently, I'm still in the process of transferring all the data from my old 3B to this new Raspberry Pi 4, but Mr. Viola claims that they should have faster speeds and should have better compatibility. So in the future, I plan to kind of use this as the balancing off platform. So the second update is the code updates and the improved algorithm for the plant. A lot of this was just refining what we had fall term and adding one or two features that would be that would kind of make the plant even better. So I would like to start off with the pain that I faced and why it took me so long to make some of the changes that I made for this for the winter term. Indent errors. So I think that's all I have to say, and I can just walk out right now. But what the issue with Python is, so for instance, in a language like Java or C++, it's based off of kind of curly bracket coding where indentation doesn't matter as long as your code is within a certain scope. Regardless of how you format it, it will run. The issue with Python is your indentation needs to be pitch perfect, or else it just doesn't work. So when you have an if statement or a for loop, for instance, your indents need to be like this much off from where you started the for loop, and so on and so forth. I had issues with indent errors the entire time. So where what had happened was I was editing code on the Pi terminal. It has an editor called Nano, which I was using to previously edit the code. But just to get a nicer IDE, I used the Thani Python IDE that came with the Raspberry Pi. And what had happened is when you edit code in two places, apparently it likes to crash and give you indent errors, which is interesting because like you'd think an indent in one place would interpret the same the other place, but it just didn't work that way. So I had to, after trying a lot to fix these indent errors, like it almost took me a week. I figured the best solution was just to kind of go back, rewrite the entire code in Nano, and then rerun the project. It worked. So yeah, so the fix was just to kind of rewrite all the code, and it wasn't a lot of code, thank goodness, but it was like quite a bit to the point where it did take me some time to recreate everything. So the other update that I had was that I edited the accept command feature that we had on the plant. So the accept command was this command right here. It's a lot of code. I'll basically go through it. It initializes a microphone and a recognizer from the text library, and all it does is it hears what you say, looks for keywords in what you said, and based on that, does a lot of logic that's right here to generate the right response. So the way we edited this was to make it so that it can actually get data from the plant. It will use the number values from the sensors and put that in your response when you ask it something. So for instance, let's say I ask my plant, what is your temperature, right? There is a res.json file that it will refer to, and the JSON file basically has, it's like a 2D list, right? You have all the possible responses and all the possible keywords that you could have. So it finds the word temperature and it goes to the response, I am $temp degrees. And you might be wondering what $temp is. $temp is a replacing variable. So what happens is when it sees $temp, the logic in the code will look for that $sign. It's like, aha, so now what follows is a variable that I need to replace. So it will go in, it will grab the sensor data from Flask. It will take that number, truncate it so that it works out, adds it in the string, into the string, and then it speaks out, I am 75.64 degrees. So just kind of fine tuning that logic and making sure it worked every time. There was a lot of issues when it came to like int to string concatenation and double to string concatenation. So just taking care of all of that was crucial to making this part work. The other thing that we added was an ask for a name function. And this essentially is when the program runs for the first time, the plant says, in a snarky way, of course, for your name. And then when it says that, you give it your name, and then it tells you, hello, Rohan, or whatever your name is, and then it proceeds with the conversation. So summarizing all of that from the last two terms, we come to kind of lessons from this. I like to call it the era of failed attempts. So the first thing was communication. And with communication, it was not so much like fall term. I think it was communication between your teammates. It was taught kind of about how you work together to get a project that works. Since I was solo this time around, I think the communication was more so with interdepartmental faculty. How do I talk to Mr. Viola when I have an issue? Or how do I even like, just go onto the internet and ask questions, things like that. The other thing was perseverance. Obviously, that was like underscored with the indent errors, because it's like a lot of trial and error. And same thing with like the code for finding the sensor variables. It was just a lot of like, when I had errors, it was just persisting through it and putting a whole bunch of print statements and seeing exactly where the error is stemming from. And a lot of the times it was just like a one-line fix, and then you realize like you spent all this time for that, but that's the whole part. That's the whole point of perseverance. Testing, kind of iterating through the software design cycle was really important. It's like when you create a project, you kind of think about how you want to design it properly. And then probably the most important part is implementation, and then revising it to make sure that it works under any circumstance. Because like multiple times what I found is that I did something to deliberately break it and it broke. So I had to make sure that if a user did something like that, it wouldn't break. And lastly, I think this is probably the most important lesson. When things fail, do what's fastest to fix it first. As long as you know the solution is somewhat like, it can hold true for a while, even if it's like a temporary fix, until you can find a permanent fix. So in other words, like grabbing the low-hanging fruit first. So kind of like go for what you can do first, and then figure out the harder problems later. So like the indent errors was, although it was a difficult problem, should have just gone for it first. And that made the process a lot more easier. Like I just rewrite the code instead of trying to fix all the indents in every single place. If I'd done that faster, the code would have worked a lot faster. Yeah, that's it. Thank you so much. I will move on to the demo. All right, so this is the demo of the PiPlant. So this right here is the front end that Sky helped me make last term. This didn't change all that much this term because it was really solid when we last left off. So this is a front end that the user can essentially use to monitor their plant. It displays temperature, the outside, the air temperature, the plant temperature, the humidity of the plant, and the moisture of the plant. So there's some graphs here for temperature and humidity that were made using D3JS. But a lot of the changes this term were made from the actual usage of the AI, right? So how you talk to the plant. So I'll actually run the script, cross my fingers, and hope it works. Ultrasonic sensors right here. So yeah, the load up time for a little bit is long, and that's something I have to fix for next time to see how to make it shorter. But here we have the ultrasonic sensor. Okay, thought my
Hey YouTube, come talk to me.
What is the temperature?
I'm 66.46 degrees. I'm burning up, you moron. Hey YouTube, how are you?
I wave my hand in front of it. How are you feeling, plant?
Doing all right.
All right, so if I wave
Hey
my hand,
YouTube, how are you?
how are you feeling, you stupid little piece of crap?
Doing all right.
Hey, plant.
Hey YouTube, how are you?
What's your humidity?
My humidity is 21.2.
Yeah, so those are just a couple examples of how it works. Yeah, so normally you have to be a little bit accurate with the way you say the words. The speech recognition app is pretty good at recognizing names as well. Like throughout my testing, whenever I say Rohan, it does recognize Rohan, but this time I heard YouTube for some reason. So it thought my name was YouTube, but it was kind of funny anyway. And you notice like when you talk, it uses your name to address you. So it says, hey, YouTube, or hey, Rohan, and it responds back to you. So yeah, that was the talking plant.
Great.
Woo.